Now, our next curtain raiser is on the topic of protecting forests with AI and satellite data. Here to tell us more, we're delighted to welcome Indra Bakker, CEO and co-founder of Overstory. Indra has a background in computational intelligence, and before co-founding Overstory, he worked as a data scientist, and he's the author of the Python Deep Learning Cookbook. Indra is on a mission to enable better decision-making about our planet by leveraging advancements in AI and satellite technology. Indra, the stage is now yours.
Hello, Kate. Thank you for the kind introduction. Let me just share the screen. So hello, everyone. My name is Indra, and today I'm going to talk about forest, AI, and satellite data. As you all know, our planet is under pressure. Deforestation is still happening at an alarming rate, and loss of biodiversity is impacting all of us today. Forest fires are raging across the globe, from the Amazon rainforest to the Arctic Circle. And these pressures are a major threat to our climate, our planet, and society. And that is why real-time data about our forest is needed to improve decision-making and to help protect our natural resources at scale. So I'm Indra, CEO and co-founder of Overstory. We apply machine learning to high-resolution satellite imagery to extract data that helps to protect our natural resources. I have a background in computational intelligence, and today I will talk about our journey so far. I will share a bit more about the advancements in satellite data and AI, and also how we apply that technology to prevent wildfires. Around 3 years ago, me and my co-founders were working in different fields. Myself as a data scientist in advertising technology, where we had lots of data and great challenges. But after learning more about climate change, I also wanted to devote my professional career on reversing climate change. And I had no prior experience in this field specifically. But myself, and I think everyone in our team, truly believes that different backgrounds and expertises are needed to solve it. And this is such a complex problem that diversity is more important than ever. And that is where Overstory comes into play. 3 years ago, we decided to focus on the topic of vegetation. And by applying machine learning to high-resolution satellite imagery, we wanted to create insights that were granular enough to improve that decision-making about our vegetation. Think about the tree height, the tree species, but also the health of the trees over time. And to make this really actionable, it has to be at scale and also refreshed regularly. So we could see also the dynamic nature of vegetation and trees over time, so that we can really make our decisions on what is changing now and not what was happening months or even years before. And this was really driven also by the growth in the satellite market space. It's an important source of information to really monitor anything on Earth at a global scale, and especially for forests, because forests cover large areas of land and they're often not easily accessible. And with this increasing number of satellite data providers, satellites in the sky, we're really fueling a real-time view of what's happening on Earth. And with this, we use different types of sensors. So we have multiple new sources also popping up every year. Think about multi and hyperspectral data that allows us to look with near-infrared bands and understand tree species and tree health in more detail. But also tri-stereo and video monitoring to extract a more 3D map of our planet and forest. And I think the real beauty and benefit of satellites is its scalability. We can monitor entire countries on a weekly basis and in some cases on a daily basis. While with drones and helicopters and even field visits, it still takes years to cover that whole area only once. But with this massive amount of data comes also a challenge, how to process it at an automatic scale so that we can extract insights from it. And that is actually where our backgrounds in machine learning play a huge role. There has been massive advancements in the field of deep learning in recent years that allows us to combine these different data sources together and fuse complementary data sets. However, these deep learning models are also very data hungry. And that's one reason why in the first years of Overstory, we spent a lot of time on partnerships and customers that had this data that we could use to train our algorithms on. Across the globe, mainly focusing now on US and Europe, but we also have data from countries like Ivory Coast and Indonesia, together with our partners. For example, we have 150,000 trees that were marked on tree level that were infested with the bark beetle, a tiny little bug that is impacting forests across Europe, but also other places. And by mapping this training data that was on tree level to our satellite imagery, we could detect patterns of early infestation. And this is really fueling also the accuracy we have. So data is really important so that we can have accurate predictions, but also improve over time. And that is actually how we as a company also grow and can have a bigger impact on our planet. By growing with new customers, it typically allows us to access more data that will make our data product also stronger and our predictions more accurate about vegetation. And this is a flying wheel that we're currently in to have a real world impact on the planet and the natural resources we have. But we make it very specific to focus on certain verticals where we can add the most value. And one of the verticals we focus on at the moment is the utility industry. And what we learned in the past years is that the intersection between vegetation and power lines is a main cause of massive fires. When they touch, there's a risk of spark and wildfire. We see this a lot in, for example, now in Western US, but also Southern Europe, it's an issue. It's not only causing wildfires, but also outages with millions of people without power and large financial consequences. At the moment, these customers, they fly helicopters and drones, but it still takes them several years to scan their entire grid only once. And with our technology, we can scan their entire grid within one day. And that brings a lot of additional value. But we always start with a base map, understanding what is there. And I'm always impressed what my colleagues are able to achieve with satellites that are hanging 600 kilometers above ground. And this very detailed 3D map gives us an information about what is impacting assets now and vice versa. But by combining that with different insights like tree species and vegetation cover, we really get insights that also can help protect forests in the future. For example, by combining the tree species with the weather, with the climate and the soil, we understand also its growth rate for the next 1 or 2 years. And this really helps our customers to plan ahead. And this is important so that they cannot only react to forest fires, which is of course very important, but if we take it one step further, we can actually help them also prevent wildfires. And that is the goal of this use case that we're focusing on. Now that we know where vegetation is, what the height of the trees is, and the species, we also look at external factors that impact them. For example, again, the bark beetle that I just talked about in the data repository, this is also hugely important for our utility customers because an outbreak at a certain spot can lead to new outbreaks closer to their power lines, which can also lead to dead trees, but also branches flying around. So this combination of scalability and up-to-date information about vegetation is crucial for our customers in this aspect. I won't go into detail here, but also verification if the work has been done by third-party contractors is important because sending out a work order is one, but we really need to know if the lines are really secure and safe. And we also have a more responsive method, and that is looking where damages are. We use SAR for that, and it's more experimental at the moment. Lots of benefits for our customers about current encroachment, so where are trees growing, but also to help them plan ahead and track and verify what has been done, and ultimately reducing the risk of these wildfires, which are growing because of the changing climate and changing weather conditions. We work with electric utilities like Red Electrica in Spain, but also NGOs like Rainforest Alliance. In total, we monitor forests and trees in more than 56 countries across the globe at the moment. And like I mentioned, this is fueling more data, which leads to more accurate insights and more value for all of our customers. And for us, this is just the beginning. Our solution can empower data-driven decision-making about all our natural resources on Earth in real time. And we really think this is a part of an important puzzle to solve or help solve climate change. But of course, it's also about how it's applied in the field. So we also work closely with customers and teams that have information from the ground that not only validate what we've been predicting, but also act on the insights that we create. And I think that's very important, why also diversity within a team is important, to really understand how can we create these insights that are also actionable for people on the ground. Currently, we have a team of 12 people. We're a very mission-driven team. Our team consists out of passionate data scientists, entrepreneurs, and utility and business experts. And we're really looking forward to connect with all of you and learn if there are any opportunities to collaborate to reverse climate change. Thank you very much.
Thank you very much, Indra, for a presentation that I think delivers quite a bit of hope. So we're going to take a short break now, and we're going to be back with you in about 10 minutes' time, and we'll see you then.